Welcome back. This is section 9.1.1, which is terminology and process of hypothesis testing. Very, very, very important. You have to read every sentence and comprehend every sentence because it's going to be so helpful for you. So today we will be talking about understanding the terminology and the whole concept of hypothesis testing. So before I dive into explaining what hypothesis testing is, I want to give you a quick example. Let's just say you want to find out. Welcome back. This is section 9.1.1. We will be jumping into hypothesis or the process of hypothesis testing, which is the beauty and heart of statistics. And I highly request, suggest, recommend you all read every page, every sentence of the notes that you have in your homework website. And it's very important you'll understand the concept. So let's dive into it and let's look at the key terms. The first word is inference, the second is claim, and the next is hypothesis testing. So let me tell you in brief what happens, what exactly is hypothesis testing. Let's just say I make a statement saying 90% of my students who take my classes pass. And for some reason you felt that's not true. What would you do? First thing, you would take a sample, right? And you would collect information and ask them, did you pass? Did you pass? Did you pass? Right? So taking the sample and collecting information and making conclusion is your inference. What I said about my classes, the statement that I made is my claim. I claim 90% of my students pass. And this process of collecting information, giving a conclusion, performing some math behind it, the whole thing is called hypothesis testing. So, what you're doing is you're either trying to prove me or disprove me. Only two things can happen. Either my statement is true or false. Right? So we will go deeper into the whole process of hypothesis testing, but I want you all to have a brief idea of what exactly is hypothesis testing. Somebody makes a claim, somebody makes a statement. As a statistician, you do the math to either prove or disprove them, and that process is called hypothesis testing. All right? Okay, so let's take a look at the first example here. An article. So the first thing you have to do is you have to understand the most key thing to doing a perfect hypothesis testing without any mistakes. You cannot avoid mistakes, but technically the first process is to understand what the claim is. So step one is to see what the other person is claiming. That's what statisticians do, right? And when you have ads on TV about weight loss or hormonal changes or any kind of prevention, they say 99% or 98.9%. They don't tell you 100% because there could be that percentage of people who might not have get cured, or this the claim that they made might not have been applicable to them. So it's always very important to understand what the claim is, what they're trying to do. So that's the first and foremost step in hypothesis testing. Understanding what the other person is claiming or what exactly is the claim. If you are doing a hypothesis testing, you need to have a claim. You either prove the claim or disprove the claim. Okay? So let's go ahead and take a look. So claim is very important. An article about search engine optimization states that on average, the number of keywords that should be targeted when creating a website is 5 keywords. An article, so a random article is about search engine optimization, is saying that when you're creating a website, you need to have 5 keywords. A website developer who's looking to increase traffic on their websites believes that the average number of keywords targeted for a website is different than the number stated by an article. So forget about statistics. Every time somebody makes a claim or somebody makes a statement, there will be people who agree with it, who disagree with it. People who agree are good, they don't do anything. But people who disagree, they always try to look for artifacts that disprove the statement. That's exactly what statistics is. So this article made a statement about optimizing your web search by using 5 keywords. So this web developer says, that's not right. I think it's not 5 keywords. It's different from 5 keywords. Now, when he says different, that could be more, that could be less, right? So let's take a look. So after completing a study, so this web developer did not keep quiet. He went ahead and studied. The web developer found that the average number of keywords targeted in the website is 5.6. So it's not 5, it's 5.6. I don't know where the 0.6 words come from, but on average. Okay, so as a web developer sets up a hypothesis test. So look what he's doing. He's setting up a hypothesis test. So it's his job now. So he has to claim something. To determine if the belief is correct, what is their claim? So I'm the web developer, and when I read an article, the article said 5 keywords. I did my study came up to 5.6. So it's different from 5. That's what I believe, right? I believed it's different. So I'm the web developer. I believed it's different from 5 keywords. So what is my claim here? Let me go ahead and take my handy dandy tool and where is it? Where is my, yeah. So the web developer, where is it? The keywords. The web developer looking to increase the traffic on their websites believes, what does he believe? That the average number of keywords targeted for the website is different from the number stated by the article. So the web developer is thinking that the average number is different from 5 keywords. That is his claim. So let's go ahead and take a look. Let me minimize this one. All right, so let me go ahead and pick a red color so I can cancel out the ones that I don't think. The average number of keywords targeted in the website is different than 5 keywords. Remember what the question is? The question is, what is the web developer's claim? The average number of keywords targeted in a website is different from 5.6. No, he's not talking it's different from 5.6. They said 5 and he thinks it's different from 5. So definitely this is not my option. The website contains more keywords. That's very abstract. The average number of keywords targeted in a website is 5 keywords. No, the web developer did not agree with the article, so this cannot be the option. What's my only option? The average number of keywords targeted in the website is different from 5 keywords. So you always have to put yourself in the brain of the web developer. He's thinking they said 5 and he thinks no, it's different from 5. So that's his claim. All right, let's look at one more example. Da 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 da. Okay. Perfect. I'm going to move this just to the side. Yeah. In a recent published article, do I have a pen? Yeah. In a recent published article, the average amount of time a stockholder owns a stock is 56. Again, take a step back. There was an article that published, and the average amount of time a stockholder owns is 56. There are only 2 things that can happen. Either you agree or you disagree. So a financial advisor, of course, there has to be someone. A financial advisor believes their clients hold a stock in less time. So this article says 56, but he thinks it's less than 56. And of course, he's interested in studying this further. So financial advisor, what does he do? Either he has to prove it or disprove it. So he collects a sample, and then the time financial advisor samples their clients and finds that the amount of time a stock was owned is 50 weeks. Well, it proves that he's right, but let's go ahead and see what they're asking us. As a financial advisor, you are trying to set up a hypothesis test. So what they're asking you is whoever is setting up the hypothesis test, you have to get into their brain. So if I'm the financial advisor, what did I say? What did I think? I thought that the clients hold stocks in less time than what? Than 56 weeks. So let's go ahead and see what my options are. The average amount of time a stockholder owns a stock is less than 56 weeks. Yeah, that's what I'm thinking as a financial advisor. The average amount of time a stockholder owns a stock is less than 50. No, that's what my sample told me. The average amount of time a stockholder owns a stock is greater. No, not greater. Stockholder should not own a stock. What does that even mean? For less than 56 weeks? No. So as a financial advisor, you're thinking the average time a stockholder owns a stock is less than what the article said. And what did the article say? 56 weeks. Okay? So always put yourself in those shoes, get into their brain, and see what they're claiming. Again, this requires a lot of practice, and you have to be very careful while you're answering. Let's look at the next one here. A business article about risk management states that average percent of IT projects that have scheduled overruns is 75%. My husband probably can answer this better. But a risk management specialist who looks for ways to reduce schedule overruns believes their strategies will result. So, look what a management specialist is believing. Get into his head. He believes that their strategies will result in schedule overrun that are below the published amount. He says, hey guys, if you use my strategies, then you will have, that's what he's believing. Again, what his belief is going to be the claim. Again, what he's going to do, he's just not going to say, hey, I believe. What does he do? He takes a sample. That's what you do. That's called hypothesis testing. If you don't agree to a statement, you have to prove it or disprove it. How do you do that? You take a sample. Sample is your lifeline. Based on the sample, based on your confidence interval, you will tell me if that is true or that's false. So slowly we are diving into the real statistics. Okay, so after sampling IT projects that followed their strategies, the specialist recorded the number of schedule overruns and found the percentage of overrun IT projects to be 62%. So this IT, the management, risk management specialist think, hey, if you follow my rules and regulations and my strategies, the overrun is going to be less than 75. And voila, when he took a sample, what did it prove? 62%. Good for him. He's going to have a good pay rate. What are they asking us? As a risk management specialist. So I'm telling you, jump into his head. Be a risk management specialist. Set up a hypothesis test to determine if the belief is correct or wrong. But what is your belief as a risk management specialist? That is your claim. Your belief is your claim. Again, my pen. Let me use blue here. So your belief is your claim, right? What did you believe? You said if you use my strategies, your schedule overrun is going to be less than 75. So let's take a look. The average percent of schedule overrun is less than 62. 62 was the data that I got from my sample. It has nothing to do with the published article. The average percentage of schedule overrun is less than 75. Yes. The average percent of schedule overrun is greater than. No, if you use my strategies, it's going to be less. That's what he said. Most IT projects have a schedule overruns. Out of your four options, there's going to be one option that just randomly throws and sits in there, like says IT projects have a schedule overrun, or IT project people are good, or something like that, which doesn't sync with the problem. So that is definitely not your option. So here your option is option B, which is average percent of schedule overrun is less than 75%. All right. Okay. Again, be very careful while you're reading. The key is to get into their head. All right, what I'm going to do now is I'm going to walk you through the process of hypothesis testing. Again, this is just a brief walkthrough. We will be doing step by step every stage of hypothesis testing in detail. So let's just take about the risk. Let's just talk about the previous example, the risk management specialist. Somebody claimed something, somebody said something, he read something about risk management in an article. And then in his mind, he's thinking, if you use my strategies, it's going to be less than 75, right? So what does he do? Step one in hypothesis testing is your claim. So once you claim it, it's either your null hypothesis or alternative hypothesis. Now I have given you the key things to remember in null hypothesis. Null hypothesis has an equal to sign. We'll talk about each and everything in detail, okay? So this is just the process. So you write your null hypothesis, your alternative. Your very important step is significance level. How confident are you? You could be doing whatever you want, but if you're not confident, that doesn't make any sense to me, right? So significance level. That's what you have to say. How confident are you? So what did the risk management specialist do? He just did not say it. What did he do? He took a sample and then he did the math. And that math is called your test statistic. Very important. You can't just claim or do whatever you want. You have to take a sample. And once you take the test statistic, what do? Either you prove or you disprove. There are two ways to do that. Either you use, where is my handy dandy pen? Da, 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 da. Yeah, I'll use a green. Either you use the critical value method or you use the p-value method. So once you take your test statistic, you have two ways to prove or disprove. Either you use the p-value method or the critical value method. So if you're using critical value, you will be using rejection regions. We'll talk about each and everything in detail, but have this table ready in every walk of your hypothesis testing. It makes it so much easier. But if you're using a p-value, p-value automatically tells you p stands for probability. So using your probability. And keep in mind in your statistics, your hypothesis testing, you are only worried about your null hypothesis. Your claim could be anything. This is the beauty of statistics. So you have your null, you have your, let me write them down here. You have your null hypothesis, which is represented by H naught, and you have your alternative, which is represented by HA. But in statistics, I only focus on my null hypothesis. What do I mean? So if my null hypothesis is true, by default, my alternative is false. If my null hypothesis is false, my alternative is true. Why? Because when you're claiming, let's say I claim 90% of my students pass. It could be true or false, right? So 90% of my students pass, or it could be 90% of my students do not pass. But both of them cannot happen. Do you see that? They're mutually exclusive. They cannot happen at the same time. So either H naught can be true or HA can be true. But in statistics, you work smart. You only focus on H naught. So if I say H naught is true, by default, HA is false. But if I say H naught is false, then by default, HA is true. Okay, so that's a trick in statistics. All right. So once you use, if you're using critical value, you use rejection region. That is, you take your normal curve and you have a region. So this is called rejection region. We'll talk in detail about each and everything. Rejection region. So when you're using critical values, you use rejection region. When you're using p-values, you use probability. Again, you only focus on null hypothesis. Either you reject it or you don't. So how do you reject your null hypothesis? If the test statistic is greater than critical value, boom, you reject. When you're rejecting null hypothesis, what does that mean? Null hypothesis is gone. That means your HA is true. And if you're using a p-value, if p is less than or equal to alpha, then you reject null hypothesis. So that means the p-value, the probability has to be less than alpha. Remember what alpha is? Alpha is significance level. Okay? All right. Again, have this sheet ready all the time when you're doing your problems. Let's go ahead and take a look at the first problem here. I always want to make sure that you see this and my face doesn't cover this up. Okay, what color? Let's just pick, I don't know, black. A stockholder is interested. Again, please read every problem like you are working out that solution. A stockholder is interested in the percentage of owned stocks that have a return on investment over 5%. So he's interested in the percentage of owned stocks that have a return of over 5%. Based on previous research, less than 20% of the stocks that have a return on the investment of 5%. The stockholder suspects that this percentage has increased in recent years. So when he looks back, only 20% of them, less than 20% of them had a return of more than 5%. And he's thinking, I suspect this has changed. Again, he's suspecting, he's not agreeing. What does he do? Take a sample, do the math, and then prove it. Okay, so let's just see what they're asking us. During the process of hypothesis testing, so this process of taking a sample, doing the math, comparing is called hypothesis testing. What values allow stockholder to create a rejection region in order to determine if there is enough evidence to support the claim? He wants to use a rejection region. So when he says that, I want to go back here. Da 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 da. So when I'm using rejection region, I'm going to go back to this chart and work my way backward. So if I am using rejection region, what do you think I need? I need critical values. So my answer is critical value. Let's look at the next one. A health insurance provider believes errors in hospital billing codes are increasing. The provider would like to test the proportion of incorrect billing codes from the hospitals in their network. He wants to test it. Again, he does a hypothesis test. He takes a sample, right? If a health insurance provider carries out a hypothesis test and writes out the alternative hypothesis, what is the complement of alternative hypothesis? Remember, let's start from the beginning. In your hypothesis testing, you have two things. One is null hypothesis, one is alternative. So if it's alternative, what is the opposite of alternative? Null. It's the complement, right? So you know that. What is a complement of alternative? Null hypothesis. So always have this chart with you when you're working these problems. All right, let's look at the next one. Can you all see, or I'll have this chart with me. Let me expand this one. Heather, a sociology major, is interested in studying mass media topics. She is particularly interested in percentage of mass media topics that relate to entertainment. Based on previous research, 72% of mass media topics related to entertainment. She suspects the percent is different. Of course, you have to either agree or disagree. So during the process of hypothesis testing, she calculated a probability. She calculated the probability to use the test. Now let me go back to the chart and see what uses probability. So I'm going to work my way backwards. So probability is what? P-value. Do you see that? So probability is associated with p-value. So if you're using rejection, it's critical value. If you're using probability, it's p-value. So always have this chart ready just because I spent some time working on it. A dietitian is interested in average amount of time teenagers exercise per week. God bless him. Based on previous studies, teenagers exercise on average of 6.5 hours per week. That's different in my house. The dietitian suspects the average has increased. During the process of hypothesis testing, the dietitian calculates a test statistic of 3.30. If the test statistic is higher than the critical value, what can the dietitian do? Okay, so it says the test statistic, the pen, it says the test statistic is higher than critical value. So let's go back to the chart. Da, da, da. So I know it's critical value, so I know I have to look in this process. Critical value, rejection. So the test statistic is greater than critical value. What do I do? When do I reject? So I know the test statistic is greater than critical value, so I'm going to work my way backward. What happens? I reject my null hypothesis. So you're working your way backward. When the test statistic is greater than critical value, you reject your null hypothesis. So you're going to go back. Because the test statistic is greater, you reject your null hypothesis. Fair enough? Always have this chart ready. I will post this right under the video so you know what you're doing. And even if you want to take a screenshot of it and have it on your phone while you're working these problems, very handy. All right? Again, if you have any questions, you will reach me through email or through Teams.